All right, so Alex, I think this is about time, so let's kick it off. Yeah.
Okay, let's get ready to rock and roll, people. So yes, welcome to our Engineering All Hands, everybody. And thank you to our designer TK for the wonderful new graphic. So, quick thing, what is Engineering All Hands? So it's a Jina community event. We run it once a month. And it's a quick summary of what's been going on, the goals we're striving towards, how the community can help get involved with those goals. It's an engineering show and tell, so our engineers get to show off the cool stuff they've been working on, and then open to Q&A, technical, product, whatever you got. And then afterwards, if we want to shoot the breeze a bit and we have time, we can do that too. So it's on the second Tuesday of every month from 2 p.m. to 3 p.m. CET, Central European Time. And, well, you've obviously all found it here on Zoom, so you're in the right place. Unless you're watching out there in YouTube land. So hello to everyone there. You'll be able to find the Zoom link and the Google Calendar link on our website at jina.ai. Yeah, and without further ado, on with the show. So
Okay.
Stop sharing, and Han or someone else can take over.
Yes. Okay. So let me take this over, and thank you, Alex, and for the introduction. And let me. Yeah. All right. So now everybody see my screen, right? Yeah, I better not make it like a full screen. So yes, so today I'm going to I want to talk like some of the pull requests that I was working on in the last 2 weeks, right? So on the at least you know, the major pull requests here, and so those are very interesting, but also in the meanwhile it's very hardcore, right? It's at a pretty low level, right? And for those who want to understand how, you know, so when I talk about Jina, right? So I always say that Jina is, you know, it's a framework like TensorFlow, PyTorch, so it has a different layers, right? So it has a very low level things like protobuf, and then on top of that we have ZeroMQ, we have NumPy, and then on top of that we have gRPC, Docker, Kubernetes, and so on, right? And so when we work at, you know, when we build this core, this framework, right? So people, our engineers and also the community, they work on different levels. So some people work on the high level or intermediate level. Some people work on the low level, right? So even though, as you can see from the pull request, from the size, you can see there are a lot of code changes refactored at the low level. But I believe all of you have, like, let's say, you know, you don't have any feeling on the high level perspective, right? So the user experience, the P part, the flow works as before, right? On the driver, on the executor side, they work as before, right? So you don't feel any changes on the high level or intermediate level. And so this is about, you know, this kind of architecture has this kind of benefits, right? So the low level changes does not affect the high level user experience, right? So specifically to the pull request that I was working on in the last 2 weeks is it's really about, you know, the basis, very low level. So as you can see here, I point all the. So 4 out of 5 pull requests are focused on the very low level, the data representation of the object in Jina, right? And there is 1 pull request is about intermediate level, but it doesn't introduce any breaking changes. Right? Okay, so let's start with the, I mean, so there are like 5 pull requests, but I will, you know, I will see. I don't have any other slides that prepare for explain them in details, but I will see whichever you have more interested, and so we can talk. You know, we can have a more elaborate talk or discussion from there. Right? So some of the pull requests I really like all of you to know, right? So even though you don't you are not using them right now, but it would be really nice for you, for all our engineers and also the community to know that, okay, Jina already has this kind of ability, which, you know, some of the pull requests that we have here is not a one-on-one mapping to the high-level features or high-level, you know, this kind of ability, but it's a feature enabler. It is a feature enabler. So by having this kind of low-level infrastructure, you can do a lot of things on the high level, right? Okay, so let's start with the with one of the earliest pull requests, which probably happens like 10 days ago, which is the introduce sparse ND array, right? And so this pull request is, you can see it's pretty big. It has 1,000 something line of changes, right? So the idea here is really to introduce introduce the sparse ND array into you know, into our protobuf level, into our data representation level, right? And so before that, so basically before this pull request, we only have one data representation for the ND array, which is basically NumPy array, but written in protobuf, right? And so this pull request not only introduce the sparse ND array, but also unifies the interface between the sparse ND array and the dense ND array, right? And so for references, before this pull request, I did some research on TensorFlow sparse tensor, how the data representation looks like. On PyTorch, they call it float tensor, a float sparse tensor, I believe. Torch.sparse.float tensor, right? And I also look at the SciPy, right? So for most of you, you probably know there in SciPy, there are a lot of, you know, sparse matrices. But notice that they call it matrices, right? Because they only support 2D, right? 2D array, right? And also, of course, Onyx. For those people who don't know Onyx, Onyx is a, you know, it's kind of a universal layer, deep learning layer, a universal deep learning language, which can unify all the TensorFlow code, PyTorch code, MXNet code, and so on, right? So to look at how Onyx design the sparse tensor really help us to, let's say, move forward, because we share more or less the same vision as Onyx, right? So we call ourselves a TensorFlow for search, but what we really is, we're sitting on top of the universal deep learning layer, right? And we don't want to be, you know, overfit to one framework. Right? Okay, so this is a kind of the background, and so the implementation, I mean, you can look at the implementation details, but what's more interesting here is I want to show you the so basically this is the first pull request I want to talk about sparse ND array, right? So basically in the sparse ND array, you know, the data representation is basically, instead of storing all the data, right, elements one by one, you only store the indexes, right? You only store the indices, the values, and also the shape. That's it, right? So basically, you can imagine these two things: the indices and values. They are, you can use dictionary, or you can use some arrays, but they are basically one-to-one mapping, right? So the number of indices should be equals to the number of values, right? And so basically this represent all non-zero elements, right? So those are the non-zero elements, non-zeros, right? And apart from that, in order to fully recover the, you know, the tensor or the matrices, just having these two values is not enough, right? So we need to have shape, right? And the shape is basically how the original ND array, what is the shape like a 4 times 5 times 6. So this is the original shape of the tensor. Okay, So basically this will be stored inside the protobuf, right? Okay, now the problem is that, okay, if we look at the protobuf, right? So let's go to the sparse. Yes. Let's just grab this code here and put it here, right? Okay. So if we look at the, if we look at the original ND array, sorry, if we look at the sparse ND array, so now it has indices, which is, represented by the dense ND array, right? And then we have values, which is represented by previously this dense ND array. And then finally, we have this dense shape, right? And so one of the very, let's say, elegant part of this pull request is that at a very low level, I unified the dense ND array and the sparse ND array into one uniform view, right? So that so when you use ND array, when you use this protobuf structure in Python, you won't notice the difference between the dense and the sparse. And the difference here is, or the conversion here is automatically done by, by the interface that I wrote in Python, right? And so that's basically, that's basically the conclude the changes on the protobuf level, right? But this only shows you, okay, so now at the protobuf level, we have the capability to represent a sparse ND array, right? And in order to fully leverage this capability, we need a Python interface, to access, to read and write from this protobuf, right? So that goes to this part, right? So if we go to Jina and then we go to the portal and then we go to the ND array, this part. So we see here, right? So this basically define, oops. I will make it. So basically in this part, in this module, we basically define the, how the Python interface of a dense array and a sparse array look like, right? And meanwhile, we also provide a generic interface for you to, to use whichever is, is possible, right? So inside the dense and sparse, if we expand this thing, we can further see that, there are different implementation of the sparse, right? If you think about this, it is true, right? So basically, sparse only, when we talk about sparseness of data representation, it only describes one data representation. It doesn't represent implementation. So when we let's say when we use sparse in PyTorch, it will be different than using sparse in TensorFlow because the data type itself is different, right? Also, when we use SciPy, it will be another sparse data type. Although inside their representation is the same, but from the objective perspective, they are different objects. So basically, this is how we shape the the sparse or dense this as an object, right? So in the sparse, we have different implementation. We have NumPy based sparse. Of course, NumPy doesn't naturally provide a sparse this kind of features, but I will explain this later. So we have PyTorch based sparse, and we have SciPy based sparse, and we have TensorFlow based sparse. Right? And fortunately, you don't have to worry about which backend you want to use, right? So basically, the generic ND array basically provides you a way saying that, okay, so now I have some array, ND array like object, right? So this ND array like object, it could be SciPy, it could be TensorFlow or whatever, right? And then basically, I use generic ND array, right? To use this interface, let's call this as ND array like object as obj, right? And then I just wrap this thing, and then I say, oh, sorry, this should be something like this, right? Value equals object, and So let's put in this way: G equals ND array and G dot value equals object. Right. So in this way, so basically, if you look at this G is now the protobuf of what we have shown here. So basically, of what we have showed here, right? But here, all the conversion and all the the implicit conversion, all the object, this kind of type recognition happens at this line, right? So basically, it uses the properties, this kind of features, and then so you don't have to worry about this. Okay, so that's that's basically concludes this pull request. And before that, for those who use ND array very often, in Jina development, you probably notice that there is an array to PB interface and also PB to array interface. Right? So those are very legacy interfaces that we have a long time ago. Right? We didn't have time to even touch those interfaces. Right? But with this new interfaces, or with this new generic ND array interface, you don't need these two functions anymore. You don't need these two helper function anymore. And you don't need to, manually assign your value. I manually write your protobuf. You just write something like this. So very Pythonic, right? Very Pythonic, right? So you don't have to work on the protobuf level anymore, right? So basically, you can say that this pull request, the first pull request, basically abstract away your daily work with protobuf on the ND array on this message type. So you don't work with protobuf level, right? You use this kind of generic ND array interface to work with these two protobufs. Yeah. Okay, so any questions so far regarding this? No? Okay. So, but let me tell you. So basically, having this sparse ND array doesn't mean anything, right? Doesn't mean we have better or richer features. Doesn't mean we have faster implementation. It doesn't mean anything, right? It only means that if your algorithm somehow needs, sparse input or somehow output something in sparse, right? Then we can handle it, right? But as you all know, you all probably know that Jina comes with core and also the hub. So a lot of concrete logic, machine learning algorithms, deep learning algorithms, also including the pre-processing, the post-processing, ranking, and so on, they are only exist in hub, right? So the core doesn't include this, functionalities of the logics, right? So basically, even though we have this sparse, PyTorch sparse support, SciPy sparse support, TensorFlow sparse support, right? If your algorithm, if your executor doesn't leverage sparseness, right, then basically it is nothing to you, right? So you won't enjoy the benefits, right? So one of the things that we can imagine is, for example, for the one-hot encoding in the text domain, in the NLP domain, right? People use token-based method and then use one-hot encoding to represent the text. Of course, it's a very trivial and naive solution, but it's still a solution, right? And so in this case, I mean, by using sparse ND array, you can get much better throughput over the network, right? And also probably it's from the computation perspective, you can also gain some benefits from that. So basically, introducing sparse ND array help us to help us to get a more compact representation of large array, so that we can be more efficient in the network transmission, right? So this is super important because Jina is a decentralized structure, right? Each component, they are in different process or even instances, and all the communication, data sharing, parameter passing, they are through RPC or 0MQ, right? So having an efficient network layer is super important, right? Okay. So that's basically concludes the Sparsend Array part. So as you can see, it's pretty low level. So even the driver, they won't notice the difference here, right? Even at the driver level. Okay. Okay. So second one, introducing another family called Classifier, right? And this I remember Pratik, you mentioned this when you first joined the company, right? So so at first I was not really, I was not really into this adding classifier, this kind of thing, because Jina is for search, right? Classification is for me is a completely different task, right? Classification, regression, this kind of thing, right? But why we still want to work on this thing, right? So it's because having classifier. So you can imagine classification as a data enrichment, as a document enrichment, right? So right now we have this document, we have this. This is a document protobuf, right? So that right now we have this very powerful representation, and then where is this tags? Yeah, here, tags, right? So we have this tags, which basically you can include a lot of key value, dictionary or strings or whatever into this tags, right? So this basically represents the meta information of a document, right? For example, so who is the author of this document? What is the original URL that you grabbed this document, and how large is the document in terms of bytes and so on, right? And so you can imagine in the future when we build Jina, using Jina in a more sophisticated way or in production, right? So sometimes we need have this tags, right? But not manually, but not write this tags manually, not assigning those tags manually, but write them in a very smart way, right? And this is basically what I'm doing here. So adding the classifier as a kind of smart annotation method that can be used to write this tags. Right? So this is basically the motivation behind this pull request, right? As you can see, so this is not as big as the previous one, and so because it's mainly about, it's not really about adding, all the executors, all the state of art, or even classic classifier, right, into this pull request. As you all remember, so those pull requests will be put into the hub, not into the core, right? So then what is exactly has to be done in the core in order to support classifier, right? And so for that, so basically, if you look at the change, you will immediately see that we have we add a new base class, right? A base executor called base classifier, right? And this base classifier has a core function called predict, right? And this predict will receive an ND array and then output an ND array, right? And so you can imagine that classifier as a kind of dimensionality reduction, right? So your input dimension is B times, let's say B times D. D is your original dimensions, and the output dimension is B times C, right? Where C is the number of classes, right? So it's basically a dimensionality reduction from D to C, right? And so that's the general interface, and that's it, right? So if I'm saying that, yeah, I want to add a classifier, so we don't need so much discussion on that, right? So when you understand what classifier is really about, right? So that's it. So that's the interface that we need to add, So with that, so all the classifier, let's say logistic regression, SVM, or even the softmax, this deep learning one, they just inherit from this classifier, right? So there's not so much magic behind that. Yeah, so that's it. So classifier itself is really nothing interesting. It is well-defined problem. It has a well-defined abstract, abstraction. So you just add this abstraction and that's it. So what is really interesting is how do you interpret this ND array, the output of the predict, right? So if you think about this, so output of the predict can be a single flattened, a B size array, which is basically, when we consider binary classification, so this could be 10 10 10 10, right? So each element represent yes, it belongs to this class, or no, it doesn't belong, right? So that's one interpretation, and in this interpretation you have the size of 1 B times 1, or simply B, right? Where B is the batch size, right? Or you say, okay, so we have B times C, right? And the C is one hot encoded, right? So each row then represent a multi-class classification problem, right? Where only single one can appear in each row, and all the remaining values are 0. Right? So this represents a multi-class classification problem, and that's also that's the second scenario. The third scenario is a multi-label, right, classification, where each row is still like a 1 0 encoded, but each row can has multiple ones, right? And finally, we have a regression problem. A regression problem could be, could be a one-dimensional regression, right? So we basically have a B times 1, as we previously do binary classification, or we have multi-dimensional regression, and this often called in machine learning. We often call this problem as a soft label. Right? So basically, on each label, on each class, we want to assign a confidence how we certain or uncertain about that class. Right? So as you can see, this is what I meant by classification is simply a dimensionality reduction problem, right? Because you can unify all the interfaces here. And the hardcore problem or the challenge here is how do you interpret this result, right, under different scenarios? Well, this comes to our driver executor, this kind of separation. So basically here we define different driver, right? And for the prediction, for the classification problem. So for example, we have very basic base label predict driver, right? So this will be inherited by binary predict driver, and also the one hot predict driver and the multi-label predict driver, right? So this is and also the yeah, so that's basically it. Yeah, so those basically conclude. So how can you use classifier? So you have to use you basically inherit from the base classifier, right? And equip this classifier or equip this executor with a correct or with a corresponding driver, right? So let's say if you build a binary classifier, then basically this binary predict driver is how you interpret the output, this ND array, right? So you use this driver to interpret, and you set 1 label and 0 label, and it's basically, this is your prediction, right? It comes from the executor, and then you basically squeeze that into, into one dimensional, and then you just say 1 or 0, 1 or 0. Right? That's it. That's how you get the label in binary classification. And one hot is basically the same thing, but it's we just do some argmax to get the label, and then we basically map them to the string, right? So very simple, right? So that's how we implement the classifier driver, and then anything beyond that is it's about testing and so on. Right? So with that, with that said, right? So this pull request, as you can see, it doesn't add any new features to Jina, right? It doesn't mean that we have better indexing, we can support better things. So it's a feature enabler at low level, right? So this allows us, allow Pratik, right, to add new classifier to the hub, right? And also the community to add new classifier to the hub. Right? So that should be very trivial by following this pull request. Okay, so oh, I see. So this is this probably. So what is this? So any questions so far on this pull request on the classifier?
Yeah, I have one question.
Yes.
Since this classifier, we are saying about classification, but the point for Jina is to enrich some metadata in the tags, for instance. That is the power
Yes.
that we can extract. Shouldn't we have added another layer of abstraction and just a classifier being an exceptional case of something that enriches your data?
Yes, I would say, so we had this discussion back in Slack channel, right? So we were thinking about, classifier, is it really something worth to be independent? Let's say, is it worth to be, one of those gear guys? This one, right? I mean, we have to ask our illustrator to add something here because right now we have, what do we have? We have classifier, we have another one, what is evaluator, right? We have two gear guys, we have two gear heads. So we have to ask our illustrator to add them. But I would say classifier, as I said, is very well defined in the machine learning community. And so when we use, when we talk about classifier, they know what it is, right? And for sure that classifier right now, it will be widely used. It will be mainly used in document enrichment. But I would say let's not limit ourselves to that. So maybe we can find more use on using the classifier. So one example is that we can use classifier to to tag certain documents and then basically to have this logic branch on the flow, right? On the flow level, right? So we can basically say, oh, this document seems, so let's say we are indexing news, text news, right? But this news comes with, sport news, comes with entertainment news, comes with politic news, right? So for each subdomain, we have a BERT model, right? But of course, we don't want to use BERT model to handle them all. We have, we got money, we spend a lot of time to train subdomain specific BERT, right? For politics, for entertainment, for games, and so on. So we want to build a simple classifier, probably based on naive Bayes or SVM, to somehow firstly tag those documents with politics, with entertainment, with games, and so on, right? And then we in the subflow, in the consequent flow, we somehow redirect them to certain branch, to certain workflow, sub workflow, so that we can do the indexing or query using subflow. Yeah.
For query intention detection as well could be.
Yeah. Yes. So in general, I would say I would welcome those the classifier to join this executor family, right? So I think it's a meaningful way, is a meaningful step, and yes.
But it's big because it's part of the machine learning community.
Yes.
Especially. Okay.
Yeah.
Han,
Yeah.
So one of the use cases of the classifier that I'm very excited about is that first we have the retrieval step, as we are doing right now, from which we get certain documents, let's say 100 documents, or let's say 10 documents, and then we re-rank them using another model which actually generates a score. So this model actually refines the result if it is using a model that was trained with learning to rank kind of system. And so that's something I look very forward to with the classifier. But I think it's not possible with the current addition, because it is more towards the adding the tag side. Rather, I would like to have that it returns the score, and then I can re-rank the results using the score. Is it possible?
Yes, because it's just, classifier is a regressor is also classifier, right? So it's just a returns a continuous or discrete value, right? So it is possible. You get the score, you get classification score, right?
Okay, awesome.
But Pratik, should this not belong to a ranker? That is exactly what a ranker does in our family.
Yeah, so what Pratik just said, this learning to rank is basically the ranker itself need to provide the train interface, and also need to adapt to what was the the feedback from the user, or from the preceding components, and so that's actually the ranker job, right? So classifier is actually not for doing that. Yeah.
I see. Okay.
Yeah.
The classifier would rather be the thing when we use think of ranking of a lambda mart or whatever, and it needs input data, that the classifier gives this input data for whatever comes in, right?
Yes. Yes.
Got it.
Yeah. Okay. So let's move quickly to the next. So the next is very, very interesting. So it's a lazy access to request body. As you can see, this one is also quite big, but it's very interesting, right? So this is something that I have in mind for a long time, and I didn't have time to do that until a couple of days ago, right? So, so the idea is, if you use Jina, right? So if you notice, in the transmission that we have, it actually involves a lot of serialization, deserialization, compression, and decompression, right? And yes. So, for example, right? So basically, when a P or when a part have accomplished their mission, right? They basically pass the message to the next part, right? And but this pass basically involves, you first have to serialize the the message into protobuf, and then later, from 0.5 we also add a compression on that. So basically, you have to serialize and compress into a binary string, and in the next part, when you receive that, you have to decompress and deserialize. You have to deserialize and decompress on that, right? And so, but of course, many of you didn't notice this procedure because it is at a very low level. It's not even at the P level. It is at the 0MQ level. So we have a 0MQ interface there, which basically did everything for you. Right? So basically, when you're at the P level, when you access a request, you already get a Python object. You can you can play with it. Right? So all this serialization, deserialization things happens at the 0MQ level. Right? And imagine we have we have a very simple. Let me just go to the. So let's say we have a very simple flow, right? So import flow. So let me make it bigger. And flow f equals flow big, and this is object, and then dot add, and then we plot that. For you to see that. So let's say we have this kind of flow, very simple, right? And we add some other parts here, right? Do we really have to? So for here, if you don't specify specify anything, then basically using this pass, which basically just pass a message to the next. Right? So in this case, as you can see, there's no point to do any serialization, deserialization here, right? So from gateway back to gateway, the whole round trip, we don't need any serialization and deserialization, and also compression and decompression here. No need at all, right? So basically, you say, yeah, so that's, that's a toy example, right? So it's nothing realistic, right? But, how about this? How about, just let's improvise something, right? So let's say this is my awesome encoder. This is BERT, right? And I have 4 of them, right? Parallel equals 3 or 4, right? Okay, so let's think about this scenario, right? So what are these 2 things here? So these are the head and the tail, right? So they basically do this, let's say, map and reduce, right? So in this case, it's very simple. It's simply receive what the previous node was a part 0, give it to it, right? And then randomly assign to one of the BERT model here, right? And the tail node or the tail P is basically collecting the result from those 4 nodes and then passing to the part 2, right? So in this case, you can see that the head and the tail, they are not doing anything fancy. They just pass a message to this. So previously, before that PR, so we basically have to do deserialization here, decompress, and then we pass a message. We have to compress and then deserialize. Right. The reason that we do this kind of thing is because we don't treat them differently. So all the paths, all the P's are here are same, right? So they inherit from the same class. So we don't have any specific logic designed for this kind of passing node, this proxy node or auxiliary node. We don't have this kind of, we don't have design logic out here, right? Okay, so this is the motivation behind this kind of thing, right? Okay, so now we know the problem, right? So we know that a certain auxiliary node, such as a route, such as pass, such as merge, they don't need to read requests. They just pass requests. They just, they just collect the request and then somehow count the number. If it is correct, then just pass it away. Right? So they don't do any algorithm inside. Right? Okay. So now, so basically after this pull request, we basically, we basically refactor the binary protocol on the ZRMQ level, to decouple the message into 2 parts, right? And the first part is serialized envelope. So the envelope part previously is already there, but it is somehow serialized inside the message. But right now we decouple these 2 things. We have envelope, we have the request, right? So these 2 things are handled, separately. Right? So basically, so the envelope part basically, let's say describe how the request will look like, some meta information about the request and some compression protocol about the request and so on, right? And the envelope part is always serialized and deserialized, but the envelope part is very, very simple. It's very, very small actually, right? And the most of the content actually is inside the request. Where the most content come from is basically the request.docs. Right, this documents is where the big size of the big data kicks in, right? So so that's part. So for the envelope, we are pretty fine with frequently serialize and deserialize, frequently compress and decompress. But we are not fine with frequently compress and deserialize this part, because this part is super big. Especially in reality, when you transfer the video data, this kind of thing, this part is super big. So we don't want to overreact on this one, right? Okay, so what is happening after this pull request is basically when you receive this kind of binary string from the network, right? So you always have the client ID is some header, and then you have the envelope is always serialized to Python, deserialized to Python object. So you can access it. You can say, okay, so what will be the request look like? What type of the request are you working on? This kind of thing, right? Okay, then we stop here, right? So basically we stop here, and that's it, right? So basically we don't decompress and we don't deserialize the request. We keep it as a binary string because we know this part is time consuming, right? So when I say time consuming is, it's not really like a 1 second or 2 seconds, but it's, probably like 50 to 100 milliseconds, this kind of time consuming, right? And, but of course, when the network, especially when the network is large and also the data that you are sending is huge, then the latency becomes more obvious, becomes more significant. Okay, so we stop here and we wait. We wait until the request, we wait until the executor or the driver that really read or write from the request. Then we do the serialization, or then we do the deserialization and decompression, right? So that's the overall logic, right? You remember that, the actual logic, the actual algorithm does not happen in P level, does not happen in 0MQ level. It happens in the driver and executor level, right? And especially for the driver, because driver is responsible for reading all the protobuf level things, reading all the request level things. So driver can basically, so if you look at the driver, if the driver doesn't read from the request, then executor will, it has no chance to read from the request. So basically, you can just say, okay, if you look at driver, you'll say, oh yeah, this driver somehow reads from request or write to the request. Then the request must be changed, right? Then we do the serialization and deserialization. Otherwise, we say, yeah, don't bother. Just pass it away, right? Just pass this message, away. Okay, so that's the logic behind that. Okay. So yeah, so that's the logic behind that, and also there's some refactoring and so on. But what I want to tell you is the envelope. So how the envelope look like, right? Where is the? Oh, here it is. Yeah. So for those who know that starting from 0.4 or 0.5, so we introduce LZ4 as kind of default compression algorithm in the for our protobuf, right? Because according to our benchmark on the internet, LZ4 basically outperforms all the other Python built-in compression, and it's very easy to set up. It's very easy to install. Just pip install it, right? And so we kind of like in the new version, we kind of have this compress config as kind of parameters here, and you can basically you can basically put your compress algorithm. You can basically specify what is the favorite compress algorithm you want to use, right? And also set the high watermark, low watermark. So those are the optimization things and also the parameters of the compression algorithm. Yes. And yeah, so that's basically about this pull request. So as you can see, then whether if it looks very simple, then why do I have to change so many codes? It's because it's actually everybody. So a lot of places we are using the request directly. So by introducing this lazy request interface, so you can basically go to the protobuf message lazy request, and then you see that, okay, so this is a lazy request Python interface that we have, and you can see this as the decompression and the serialization, this kind of thing, right? So basically I have to replace basically every time you use the code is using request to this lazy request. And meanwhile, I have to make sure that you know, from the code logic, it doesn't randomly access the request if it is unnecessary, right? Basically to somehow preserve this kind of laziness for the lazy request, right? So for those who are interested in this kind of implementation, you can read the code, and it's very easy to understand that. And also you can also read the proto message, which basically as a wrapper of the message itself, of the protobuf message itself, and basically provides all the you know, all the, let's say for example, this add exception is very useful later on in the next pull request, merge envelope, add version, you know, check version, size, add route, this kind of thing, right? So as yes, as you can see, so previously those functions, you know, are spread all over the places, right? So right now I'm combining them everything into this proto message interface, right? So this is basically about the pull request. Yeah. So as you can see, this is on the very low level. It's on the protobuf level. So it's really at the bottom, very bottom of the cake, of this big cake. So any questions so far regarding this one? All right. I guess this is a very, you know, very low level one. Yes. Okay, so the other thing is about this improved exception handling. So this is relatively, yeah, I don't remember why this takes so much effort, but I think this is, so we basically, so the problem here is previously we have this exception, and this exception is either thrown away during the flow, right? During the workflow, or it is not explicitly visualized, right? And so basically this pull request is about refactoring the exception on the protobuf level. So basically define what does that mean by exception at the protobuf level, right? So here we have, we basically have a message called exception, and then here we have name, argument, stacks. Stack is basically the traceback, and also executor, the driver. This is basically the exception structure, right? And then, so when we throw an exception somewhere in the executor, in the driver, we basically want to fill in this exception structure and then pass it forward, right? So here, this is a pull request, right? So it is very obvious. I mean, so you get this, okay, so something happened in R2, right? And so we basically put a, you know, red cross mark here and then pass it forward. Right? So I think this pull request also fixed some problems about exception passing and also exception handling, right? So basically to make sure that the flow will not break because of the exception you know, happened in the middle, right? Another thing is I also add some logic on, you know, passing the exception to the client, right? So this is super important because you know, when you run Jina in production, it is always decentralized, right? In the decentralized environment, where the flow is on one machine and your client is probably on your local MacBook, you know, or, you know, Linux system. And you don't want to have a user experience that you send something to the server and then it hangs there forever. You don't know what happens on the server until you SSH into that server, right? So previously it was like that, right? So the user experience is like that because when it, you know, when it has some errors, it basically interrupts the whole flow. And then you as a client, right, you cannot see that. The reason that you can see that right now because you run Jina on one machine on your laptop, right? So that's why you are kind of like a god. You can see everywhere. You can see everything, right? But in reality, you are not God, right? You can only see the client side. side. You cannot see what happens on the server side, right? So after this pull request, if something is wrong, right, as you can see, this table is generated after the gateway. It means that this table is generated on your client side, not on the server side, right? So that's basically kind of like a user experience optimization here, right? And yeah, so basically here I also add some, you know, some refactor, some exceptions and so on, right? Okay, so any question regarding this one? Okay, so now we move to the last one, which is also not very easy to explain, but it's also like also very low level on the protobuf refactoring. Oh, sorry, not on protobuf, on the reduced driver refactoring, this kind of thing. I know Joan has, you know, a lot of interest in that. But let me say that. So first of all, I do spend quite some time to really think about what the reduced driver should look like. As you can see, right? As you can see, I actually have 2 pull requests happens, you know, in the SQL, right? The first pull request happens in the order, right? The first pull request is basically I move the reduced logic to the base driver, right? And in the second pull request, yes, and in the second pull request, I even move the reduced logic to the P, right? So basically the but these two, so basically I'm lifting the role of reducing from the driver, from a particular driver called reduce driver to a general driver called base driver, and finally to the P, right? Which is basically not driver related. So this is basically, yeah.
Han, yeah, I just wanted to mention that when me and Bo were designing the multimodal driver, we had a first thought about having it part of a reduced driver and mix these 2 logics together. And then luckily we decided to split it and we separate these 2 orthogonal concepts. Just a mention of these problems that we were facing with this driver.
Yeah. So basically, you know, so let me show you. So basically, this 2 part is very, very relevant. And if you are not using parallelization in Jina enough, it's probably very hard to you to understand what I'm talking about right now, right? Because if you use Jina in this way, right? In this chain, in this sequential way, right? Or even in this bird way, in this kind of parallelization, if you are not using sharding, this kind of broadcasting, this kind of feature, right, then you don't know what I'm talking about right now. So basically, the reduce is about collecting the results, right, and you know, to gather them together. So let's take an example. So for example, this inspect. This inspect is something that we add in the 0.7, right? So this inspect is basically kind of, you know, like debugging in the Python code where you can just, you can have multiple inspect, this kind of thing. So let's add this is my, you know, this is my encoder, and this is my indexer, right? And then I inspect because I want to check, you know, I want to check the L2 distance between the ground truths and your encoded result. And here I want to check, you know, I want to check the, I don't know, I want to check the number of documents, right? I want to check the number of documents. It is somehow, you know, fit to what I have as a ground truth. Okay, so with that, we have this kind of graph. We have this kind of flow, right? I mean, yeah, so we have encoder. So I mean, you can first ignore the dashed line, right? Because the dashed line is kind of auxiliary things that we added for the inspection, right? And we only so basically the solid line represent, you know, the real workflow, right? And in the meanwhile, we have the dashed line, which basically adds some evaluation node or inspect node to the flow, right? Which labeled in red color. And then eventually we want to collect the inspection, right? We want to collect the inspection. And so this is how we do it, right? But unfortunately, this doesn't work before this pull request, right? Partially because reduce driver and partially because the num part, this partial message that we have in the message protocol, right? Because of these two things, this architecture, although it looks very beautiful, right, it doesn't work. Right? What I mean doesn't work is that when you run something, for example, when you run flow, right, with f, so when you run f, right, and then type, oops, sorry, and then when you type f.index something, it doesn't do anything, right? It will break because the network workflow, it doesn't work. And so the reason, so the refactoring is really about enabling this kind of architecture, right? And also something like that, right? So let me write another architecture, right? So flow.add. So let's put a and then flow.add, and then let's call it name.p1, right? We don't need name here. Yes, we do. Yeah. Okay. So let's copy paste this in 2, but meanwhile here we need gateway. So this can be also, Paul and Joan, you can also think about this because I see one of your integration tests also has this kind of structure, right? And finally, we need all, right? So we need what we have here, P1, we have P2, we have P3, right? And then let's plot it. Okay. So this is a structure, right? So this is a structure that we have. So notice that this one is somehow different with the with the bird that we have because let's say we can add a parallel here, right? We can add a parallel here, and this becomes something like this, right? So you can see that the pub sub, the publish, the broadcast happens at pod level, not as a P level, right? So this is how it goes, right? And I mean, so right now this kind of, so let's first remove this parallel because this is too too complicated. Okay, now let's back to this normal one, right? So before this pull request, this kind of thing is doable because why is doable? Because the num part basically defines how many partial message the downstream should expect, right? And the num part is set in the upstream. So basically here, when the gateway sends this thing to the three downstream part, it sets the num part in the envelope or in the header, saying that, okay, downstream, please notice that there are 3 partial messages that you want to collect later, right? And so this downstream message, this downstream part, basically, when you equip it with a base driver, not base driver, but with a reduced driver, it will trigger them, right? So only reduced driver will be triggered by the num part. This kind of, this kind of properties. The reduced driver will say, yeah, the envelope tell me to wait until I receive 3 messages, right? Then I can continue, right? So all the other driver, well, this doesn't make any sense to them, right? They just ignore this field. They are not triggered by this field, right? Only a reduced driver is triggered, right? So what is the problem of this kind of design, right? The problem is that if the num part is completely decided by upstream, right? So what happens in this kind of scenario? So if I change this to P1 and P2, if I call this reduce 1, and I need again P3 and reduce 1, and I call it reduce 2. Okay, look at this flow, right? And think about what I just said. The upstream decide and tells the downstream, right? So how many partial message you should wait or you should collect, right? Is that legit here? Right, so here you see the gateway say, yeah, please wait for 3 messages because I just sent out 3, right? Here, what is R1 here? So the R1 is basically collect the P1 and P2 into, let's say this is embedding concatenation, right? And this P3 that we somehow, using another, whatever, this deep learning network to do the R2. So as you can see here, I wait only 2 messages. Here, I only wait 2 messages. Then the num_part equals 3 means nothing to me because none of this reducer respects that value, right? So this is exactly the flow that doesn't work previously before this pull request, right? And this flow is very general. As you can see, they will be used in the inspection, in the evaluation mode. It will be used in multimodality, right? Where this is text modality, this is image modality, you combine them into text image modality, and this is whatever the audio modality, and then you combine to this all sensing modality, right? So this is a very general problem, right? But given the design, the previous design of reducer and also the num_part, we cannot do that, right? Okay, so now the problem is, okay, so don't let the solution is pretty simple, right? So once we understand the problem, the solution is actually pretty simple, right? Don't let the upstream to decide how many messages you want to collect, right? Let the downstream to decide, and that's it. So that's the spirit. That's the spirit of this pull request. Let the downstream decide, right? Because you never know what is the downstream look like when you write the upstream, right? So when I build the flow from this here, I never know what will be the downstream because this is always like one pass from up to down, right? So you never know what about the downstream or how the downstream look like. So let's just let the downstream decide. Let the downstream set the num_part, right? And that's it, right? Of course, you say, okay, so that's kind of it's somehow, where is the pull request? Is changed. It changes the original definition of num_part, right? It is true. Yes, we changed the original definition. So the semantic of num_part. Okay, so this is also one. This pull request also explains what is going on there. But if you are interested, you can also say, but it's basically what I just said. Right? So basically, I changed the semantic of num_part to the number of messages that expected from the upstream, rather than previously it was the number of messages to be sent to the downstream, right? So now it's the number of messages expected from the upstream, right? Right. So that's it. So that's basically by setting the num_part on the downstream, you can enable this, and basically that's a pull request is about. But how about the driver, right? So the reduce driver and all the other things. Why are they? Why am I moving them? Over the place, right? So the thing about reduce driver, the previous reduce driver designed in a way so that the reduce driver itself is very, very orthogonal to all the other drivers. So what does that mean? So basically that means when you use reduce driver, you cannot use other driver. Basically the function of reduce driver becomes independent. Let's say the reduce driver only carries one functionality. It's basically reduce, right? If you want to say, yeah, I want to meanwhile encode and reduce, then you basically have to, somehow, I don't know how to write this thing. So it's because it's very orthogonal. You either have to somehow mix in the encoded driver with the reduced driver, right? And then put the two logics together. Because the reduced driver, or you completely rewrite the reduce, the logic here, right? By basically copy paste what the encoder driver looks like. Right? And this is one problem. The other problem is you cannot perform. So basically, what I'm thinking is that reduction and the previous message. So basically, the message that we collected here, we collected at reducer at R1, R2, R3, R4. Those messages, right? So there's two messages here, and for R3 we have two messages here. For R4 we also have two messages here. Those previous messages should not be accessible only to the reduced driver. It should be accessible to all drivers, whether it is about craft driver, it's about encoder driver. They should all access whatever you collected here, right? So basically, this kind of needs, this kind of partial message collection should be done at the P level, right? It should, at the P level, you should collect this kind of thing, and then the driver level can have the access to all the previous message, to all the collected message here, right? So that's basically the spirit or the merit of this pull request. Yes. And yes, so that's basically so any questions so far regarding?
Does this directly translate to sharding? That after sharding you use the merge all, which is also some kind of a reduced driver. This also automatically happens as long as you have something after the. So how,
exactly. So that's not merge all, because merge all is different. Merge all is still like merge all is still like a merge all. It's a still reduce all driver, right? But if you look like the general reduce driver, so the simple reduce driver, the simple reduce driver is now put to the control driver, which is simply a route driver, right? Reduce driver is basically, previously reduce driver is combining all the message envelope. And and don't do anything about the message, the request itself. Just combine all the message envelope and then pass forward. And so after this refactoring, the reduce driver is not required anymore, because the basic reduce function, right? Collecting request, and combine this request, combine the envelope of this request. Those functionality has been lifted to the base P, right? So the driver, all the drivers share this functionality, share these features, right? So that's why we don't need a base reduce driver anymore, right? So the reduce driver is now just a pass, right? Just a pass. And speaking of that, right? I'm very, very interesting that previously we have a forward driver, we have a route driver, we have forward driver is a basic pass, and route driver is a pass with a load balance, right? And then we have a merge driver which combines everything. And now, at this point, and we are very proud to say that all the paths equals to route driver. So this basically rules everything. And this route driver, you can use it in any kind of topology, right? Whether it is, load balancing. So basically, let's use this example here. So let's say we have P3 is, let's add some parallel here. Parallel. Suddenly, I forgot how the parallel should be spelled. Okay, here. So, for all the things here, you can all use paths, right? So here, you can previously as a route driver, because here you have to load balance all these things. And previously, if you use sharding here, then this has to be merged, and then this has to be merged, and then this is path or something like that. So right now, if you build some graph like this, if you look at the drivers that equip it, all of them are paths. right? So this is a very, very beautiful. And so it's unify all the simple driver interface for all of them. And meanwhile, is it is feel more natural, and also it also improves the speed quite a bit, right? So remember combining this pull request with the previous lazy request, right? The merge driver and the pass driver, they don't touch the request body, right? So it leverages the lazy request, this kind of features. So the overall network latency is much faster, right? Sorry, latency is very much smaller. Yeah. Yes. So that's basically concludes some low level works that I've conducted in the last 2 months, the last 2 weeks. Yeah. All right. So we only have 10 minutes, and so what do we have here? So besides the pull request here, how is our community? Yeah.
There is a question
John,
from the
please.
community in YouTube that I'm not sure what it means, but maybe you are able to answer correctly. It says, does Jina has off-the-shelf text extraction as well? It's asked by Bushan. I hope I pronounce it properly.
Text extraction.
Yes. I think we have a PDF text extractor, and we are easy to expand for custom use cases. But I'm not sure what we are referring here.
Is that name entity recognition or something like that?
Not sure. I welcome him or her to say something in the chat.
Yes. So right now we don't have name entity recognition because that's too, let's say, too domain specific. Yeah. If we have, then it should be put that into the hub.
Actually, for name entity recognition, it's actually somehow related to the document enrichment. For the classic, I mean, currently we already have the classifier, but the output of the classifier is a list of kind of a list of a fixed length. But if we're talking about key phrase extraction or name entity recognition, then output would be a list of unfixed length. So it will be a new kind of a new executor, let's say. Or we can do one layer abstract for classifier, and this kind of we can have one layer of abstraction for document enricher, something like that.
I hope it answers his question.
Mm-hmm.
Yes. So any other question from Florian?
Hello.
Hi.
I have a question related to your multi-document search. So at the moment, we consider an image or an audio file as a document and then do our search with this. And so when I, for instance, worked at SoundCloud, so each user has multiple audio files where the user is interested in. And so for this, it was quite good to search or to have multiple audio files as input for one search request. So consider the user as a document, and then having a lot of chunks, and each chunk is one audio file, for instance. And also I worked at Deep Face Match, where we had talents, and each talent has multiple pictures. And finding similar talents doesn't mean one picture of each talent has to match, but all pictures have to kind of match. So in that case, a document would be one talent, and each chunk would be one picture. So how I would implement this in this kind of usage in Jina would be to have an initial multi image chunker or so, where you give in an ND array, and then it emits a lot of single image chunks. But I thought creating this kind of this kind of class for all the use cases would be a bit redundant. So for image, for video, for audio, maybe there would be a common solution for these kind of search. What do you think?
Yeah, so do we have someone join maybe? Because I think it's somehow related to the granularity that we previously explored. Yeah.
I actually think that with our really with our recursive structure, we can be flexible enough to tackle this problem. If we consider a document, instead of the content to be the document, just the chunks to be the images, with our aggregator chunk to doc rankers, I think we can fulfill this way of working. I think the point is, even if we consider that the score should be aggregated because one talent is an aggregation of functions, this can be covered by having a document as an assemble of chunks. And for me, the main driver is the index is queried by one image at a time. If we have to merge the embeddings of all these images, then we go into multimodality. I think Jina is flexible to handle this kind of stuff with the current architecture.
I think I agree. And you can, I mean, in the end, when you have this idea that one talent has multiple pictures, you can somehow, exactly what you just said, search for each picture somehow all the results, and then the magic must happen on the ranking function. And I think that should be straightforward to do this. The ranking function then needs to take, in the SoundCloud example, where you just one has to match, somehow just get the best matches and return them. And then the deep face example has to take care that as many pictures as possible matches, and rank somehow up in as how many have matched.
Mm-hmm. Thank you. Can I ask another question as well?
Sure.
So currently there, I think it doesn't prevent a lot the user to do some misconfigurations. So for instance, so user as a developer using Jina. So for instance, you create your flow and you use an index which uses similarity measure, but then you use a min ranker which converts the normally distance into a similarity measure, because at the end we want to have a a higher score means a higher relevance in the search. So, but this would not be allowed actually, or we know exactly that this must be a misconfiguration, but at the moment we don't reveal this to the user. And should we do this, or does the Jina user have the full responsibility of the whole flow, how it's configured?
I don't understand. So your argument is distances somehow are always somehow ascending. The smaller the better. And if you use a min ranker and you somehow,
I mean, for instance, a similarity metric can be negative, which means that something is very dissimilar. But a distance will always be positive. And if we use a ranker, which assumes that the values, the inputting values, are always positive, but in fact it's not, we could put a warning to the user or even let the whole flow creation fail, because we know for sure it will fail at some point because of these negative values.
One thing from my side, I think one aim that we should go for is to have as much isolation as possible from every pod into another, and as much reasoning it can be to have the less assumptions possible, for now at least. I don't know if it's.
So I think the Florian's question is somehow related with Christian's post on this, because he just joined our company and he also have trouble on the min rank and also the distance. There's inconsistent in terms of semantic, right? So one is about distance, the lower the better. One is about score, the higher the better. Right? So those inconsistencies are not really explicit to the user right now, and let's say without for newbies who not really pay attention, so this could be very misleading or could be a pitfall or coverage, right? But the thing is that if you think about Jina as a framework, as a programming language for the search system, right? Having this kind of, let's say, pre-compiling, right? Having this pre-compiling and static analysis. I mean, this is a metaphor, right? So you use this static analysis and pre-compiling to to filter out those errors before we even start the flow, right? This is of course something I would say doable, but it has, and you can imagine the difficulty here, because Jina as a programming, as a design pattern, as a programming language for the search, it offers very high flexibility, right? So you can actually put together in any way you like. As you can see here, the flow, you can design your own flow in in different orders, in different parallelism, and all different different decentralized architecture, right? So basically, to filter out the error in advance is nothing, it's not easier than just run the flow itself, right? Just run the flow and get the error, get the exception, when you run the flow. Right, so I would say, but in Jina, in the current version, since 0.5, we introduce a dry run function in the flow. So basically, when you do the index, when you do the search, you will basically send a small request as a headless request, as a contentless request, to mimic what would the flow look like when I just send a toy example to the flow, right? But so currently this dry run only they only guarantee the validity or the connectivity of the flow, right? So basically it doesn't guarantee it doesn't do any sanity check on the result. It only guarantees the connectivity on the flow, right? So, but I would think if you are interested in this direction, right, then maybe we can add some payload to the dry run, right, to make a small sanity check. But you can imagine it needs some experience, it needs some abstraction from the daily use cases, and notice that, okay, so given this kind of input, toy example, I run this very small integration test called dry run, right? And what are the expected output should look like, right? And then based on the expected output, I do some assertion and then check the validity of the flow. Right? So does that make sense to you, Florian?
Yes, thank you for the answer.
Yeah. right, so I think that's because we have another meeting right now. So the all of our in-house engineers have to leave, and so do we have more requests or like questions from the community? Okay, so no other things. Yeah. Yeah, I think that's it. That's for maybe I hand over to Alex for the quick conclusion, and then we can. Yeah. Okay, Alex is not there. Okay, so all right, then thanks everybody for joining this Engineering All Hands, and I will see you guys next month at the same time. Okay, thanks everybody. Bye bye.
Bye bye.
Bye bye.
Bye.